All right, so let's talk a little bit more about what exactly is this line that we're looking at. This is called the least squares regression line. Um, and the way that this is found is we take and put a line through our data points, and then for each point, we take the value of the point and subtract the same value on the line. Okay, so we're looking at that independent variable. So whatever, when we plug that x value or that independent variable value in, we'll get a value off the line, and then we have the value from our data point, and we'll subtract those. And what we do with those is we square each one of them, and we add them all up. And we do that for a variety of different lines. And what we're looking for is the line that gets the smallest possible total from this process. Okay, so let's actually take a look picture-wise at what that is, because this is kind of hard to visualize. All right, so here is a data set that I loaded up. It has average teacher salaries as our independent variable and average spending per student as our dependent variable. Okay, and we can work on fitting a line in here. Let me show you how to do that. All right, so I can use these sliders on the side here to adjust the slope and the intercept. So I can kind of play around with this a little bit and see if I can get something that looks like it's a pretty good fit. All right, so that doesn't look too bad. And then I can click this line. So here they've calculated they're showing us all the different residuals from the points. And then here's what it looks like when they square them. Okay, so they're adding up the area of all of these squares here. And they're looking for the smallest possible sum. So here we have a little meter here that tells us what the sum is. So if I wander this thing off really far from the points, you can see that sum is just getting larger and larger. And I can kind of play around with it and see if I can get it to give me a smaller sum, right? So I could spend a lot of time playing with the sliders and figure that out. Here is the line of best fit. So actually not too far from where I stopped at. Let me get rid of my line. So there's the line of best fit. And again, we can see the residuals and the squared residuals. So they're adding up all of these areas here. And they're looking for the smallest possible sum. And that's how we get our least squares regression line. Okay. Now, obviously, there's some math you can do to find this, so it's not just trial and error and adding all of these up, but that is definitely something for a more sophisticated course. Right now, I just want you to understand that that's kind of how they're fitting those together. All right, so here is that equation in that picture again that we were looking at, and our y equals mx plus b. So we do have a formula for calculating these, and we won't be calculating these this way in this class. But there is a formula. The proof for that is something that you would see in another class. But to get your slope, you're going to take the standard deviation of your y variable, your dependent variable, and divide it by the standard deviation of your independent variable. Remember that standard deviation has to be positive, or I guess worst case scenario is 0, but it has to be positive. So when I divide those two, I'm going to get a positive number. And then I'm going to multiply that by r, which is my correlation coefficient. So that slope of the line, whether it's positive or negative, is controlled by that r. So that's why we get that matchup that r tells us the direction of our data. And then to get our intercept, we would take the average or the mean of our y variable. And then we would also take the slope and multiply it by the average of our x variable, and then we would subtract those two. So that's where they're getting the equation from. The proof behind that is a little bit more work, but not too terrible.